All right, what's up, everybody? So this video is intended to serve as the walkthrough or recording for understanding probability. Now, by this point in the semester, we've already covered kind of a broad introduction to what is behavioral statistics. We've discussed frequency distributions, measures of central tendency, and measures of variability. So by this point, we're going to be taking some of those principles that we've learned already in the first few weeks of the semester and continue applying them to this idea that we're now being introduced to called probability. So as far as knowledge building, as a reminder, I'm always trying to get y'all to understand how it is that what we're discussing now very explicitly ties into things that we've covered already. So we're going to build specifically on frequency distributions from Module 2, while we are, broadly pulling from measures of central tendency in Module 3. We're actually focusing a little bit more specifically on the mean, right? So we're going to be bringing back this concept of the average of your scores, and we're going to be using this as a part of understanding how probability functions. We're also going to be pulling some information from broadly measures of variability and a little bit more specifically from this idea of standard deviation. Now, as a reminder of standard deviation, it is the average distance or deviations a score is from the data's mean. So, as I mentioned, moving forward in this presentation, we're going to see how these concepts kind of are implicated in what it is that we're discussing in probability. So, we're going to talk about this in the context of this game Gongji. And if you are a Squid Games fan, particularly Squid Game Season 2, they played this game called Gongji. And if you don't remember which game it was, or maybe you're not familiar with it, that's okay. I'm going to introduce you to it in just a few moments here. But first, I want to give you a definition for what probability is. As a definition, probability is the relative likelihood of an outcome or event happening. You've very likely heard of this idea of probability before, and maybe you've even applied this concept, this mathematical concept of probability to things that you've interacted with in your life. And we're going to see how it applies specifically in the world of behavioral statistics and social sciences. Written as a formula, we can say that that probability is the number of times a specific outcome or event can occur over the total number of times that any outcome or event can occur. All right, so the specific times, the number of times a specific event occurs over the total number of times that any event can occur. There are a couple ways that we can discuss reporting probabilities. So probabilities can be reported as fractions, as decimals, or as percentages. For example, let's say we're talking about flipping a coin. Now, if you're familiar with any kind of standard coin that we have here in the US, you'll typically have, I'm talking about coin, I'm thinking about money, right? So let's even think about this in the context of a quarter. If you have a quarter, the quarter has two sides. There's a side that is heads and a side that is tails. So using that as an example, we can describe this first area here as telling us that we're discussing the probability. This P represents probability of tails, okay? So of specifically getting a tails if we flip the coin. Now, if you think about a coin, you have a total of two possible outcomes when you flip it, right? You're either going to land on one side or you'll land on the other. On one side, you have heads. On the other side, you have tails. If I'm asking, or if we're discussing specifically the probability of getting tails, then the number of tails on the head is only one, but the number of total possible outcomes is two, right? Both heads and tails. So to set that up in a fraction, we would write the number of times the specific event occurs, so getting tails, there's one chance to get tails, over the total number of times that any event can occur. And so that's where the two sides of the coin come in to represent two as our total number of any outcomes. We can also convert that into a decimal. If you divide 1 by 2 in a calculator, you will get 0.5, and so that is our decimal form for probability. We can also then convert that into a percentage. If we move the decimal 2 places to the right, or if we take that decimal 0.5, multiply it by 100, it will give us a percentage, and that is 50%. So the probability of flipping a tails or flipping a coin and getting tails is 1 out of 2, or 0.5, or 50%. It's important to note that all probabilities exist between 0, which means that something will never possibly happen, and 1, which means that it will always happen. Now, both of these numbers, 0 and 1 in this last statement, can be also converted into decimals and into percentages. But I didn't want to confuse anybody, so just think of it as, it's possible that something can never occur versus it's possible that something can always occur. And all probabilities exist within that window, so to speak. All right, so let's take this example of the Squid Games game, Gongji. Okay, so in this game you have 5 game pieces, and this image that I have in this PowerPoint on the screen are the 5 game pieces that we saw in I say we because I watched it. Of course I watched it. That we saw in Squid Games 2. They had 5 game pieces. Each game piece is a different color. If you pay attention to the shapes that are drawn onto the game pieces, there are a total of 3 unique shapes. Now you can kind of see them displayed here in the image. 2 pieces are triangles, 2 pieces are circles, and 1 piece is a square. And so for discussing probability with this example, I'm actually going to focus only on the shapes component of these game pieces and not on the color component. Okay, so we're kind of abandoning thinking about the color of these game pieces and focusing more specifically on the specific shapes that these game pieces have. So in the game Gongji, there are 5 game pieces. As I mentioned, there are 3 unique shapes. In total, we have triangle, circle, and square. If I were to ask you, what is the probability of randomly drawing, like let's say I have the game pieces in my hands, I present them to someone, I say, I want you to close your eyes and draw one of these game pieces. If we were to discuss the probability of someone randomly drawing a circle, we would have to consider how many possibilities is there to draw a circle over how many total possibilities there are. Okay, and so that's where thinking about how we present and report probabilities comes into play. So we can write this as the P. Remember, P represents probability. The probability of pulling a circle is equal to 2 out of 5. In this case, the 2 in our numerator represents how many game pieces have a circle on it, where the 5 in the denominator represents how many total game pieces there are. So let's take this same idea of probability and apply it to all of the different shapes that are potential game pieces that can be drawn if we did just that, right? Remember, hold them in our hands and present them to someone and say, close your eyes and randomly draw, a game piece. We can determine the probability of randomly pulling any shape in Gongji. The probability of randomly pulling a circle is, as we mentioned on the previous slide, the probability of circle is 2 out of 5. Remember, we have a total of 2 circle game pieces with, we have 2 circle game pieces with a total of 5 game pieces available. The probability of randomly pulling a triangle, so we would want to count how many of our game pieces have triangles. In this case, we have 2 game pieces that have triangles over the total number of game pieces available, again, a total of 5. And so to set that in a probability format, we would write the probability of drawing a triangle is 2 out of 5. And then finally, if we were to ask the question, what is the probability of randomly pulling a square? If you're able to remember what the game pieces are, or if you're familiar with the game, there is only 1 square game piece. And so to set this up in probability form, we would write down that the probability of pulling a square is 1 out of 5. There's only 1 game piece, but there's still a total of 5 of them available. So let's discuss graphing probability. So based on our probability calculations, we can make a graph that represents the number of times we can randomly pull a circle. Really, the graph that I'm going to show you is representing how many times it's possible to pull any shape game piece, and you'll see that represented in just a moment. So here we have the graph. We have for this first bar representing our circles, we have two possible chances that we could draw a circle, two possible chances that we could draw a triangle, one possible chance that we can draw a square. Now, the only thing that I don't like about this graph, and I say this because I was trying to edit the graph so that instead of stopping on our y-axis at a total number of draws at 2.5, I would actually want to draw it out of 5. And so I apologize that I wasn't able to figure out how to get it to show a y-axis of 5. Because again, I want to represent the idea that it is possible technically that if I were to hold, all 5 game pieces in my hand, I had someone draw a random game piece and then, record that and then put it back, I could technically have someone draw a circle all 5 times, right? It's literally possible. And so I wanted to represent this graph out of a total of 5 draws. However, like I said, couldn't make it work for me. But again, this graph represents what the probabilities of drawing each of these game piece shapes. So using a bar graph, the total number of draws is on the y-axis, again, should be 5, and the list of possible shapes is placed on the x-axis, just to demonstrate what we should see happening with this idea of probability. Now, you might have noticed the language that I used just then was actually very intentional, what we should see happening. And there's a reason that I'm describing this idea of probability as should. So in frequency distributions that we were first introduced to in Module 2, we were discussing that tables, and really there are a variety of ways that we could represent data, including graphs, are these formats of being able to summarize and organize raw data. It's important to note, though, that frequency distributions are based on actual observations. That is, that frequency distributions are based on data that we have collected through our research observations, what we have seen happen. It sounds kind of odd to describe it that way. Excuse me. Excuse me. But in an example of me distributing a survey and collecting that data and using it to produce a frequency distribution, that's data that I've collected, right? I've created this survey, I've gone out, I've asked people to take this survey, I bring this data back, I'm entering it into some sort of data program, and then I'm producing frequency distributions. And so I want to emphasize here that frequency distributions are based on actual observations, things that we have seen happen. And so that's a frequency distribution. Probability distributions, on the other hand, can also be created. However, probability distributions are based on theoretical observations. That is what we should see. In this example of discussing the game of Gongji, we're describing these scenarios where we're holding the game pieces in our hand, we're asking someone to randomly draw, and we're discussing what we should see happen. It is probable 2 out of 5 times that someone is going to draw a circle. It is probable that 2 out of 5 times someone is going to draw a triangle. And finally, it is probable that 1 out of 5 times someone will draw a square. However, in this scenario that we're discussing, we're not actually having anybody draw these random game pieces. Now, if we were, working with this material in a classroom setting, I'd be able to kind of represent this activity that I'm discussing. And if I actually have some Gongji game pieces. I don't have them with me right now. But in that, I'm going to pause this video. So you're going to see like a little glitch where I pause it and then restart it. Give me just a moment.